Towfish that can move in 2 or 3 dimensions are particularly useful for surveys. These tend to be called remotely operated towed vehicles, ROTVs, and I'll tell you about that in about 2 minutes. ROTVs tend to rely on accurately controlled movable fins rather than gravity to fly down to the seafloor. They're inherently very stable, with a roll limited to maybe 1 degree. Normally, the faster you survey an area, the more cost effective it is. In order to look for unexploded ordnance, however, it's advantageous to get as close to the seabed as possible, maybe 3 metres above the surface. And so the ROTV uses an altimeter to accurately measure the distance between the seabed and itself, and if it drifts up past that 3 metre threshold, the angle of the fins change and automatically bring the body back to the correct level. But as the distance between the vehicle and the seabed closes, the apparent ground speed increases, and it becomes very difficult to carry out scanning, as a vehicle is sometimes moving too fast for the capacity of the sensor. Which is why you need a vehicle that actually can fly at low speeds, maybe down to 1.5 knots. Now the problem with going slower is that the ROTV becomes far more affected by side currents than it did when it was going fast, and the body starts to drift if not corrected for, and that's why they sometimes have side fins. It's worth looking at these in a bit more detail for a few minutes, because the ROTV, which normally has sensors within the body, can actually be used to tow other towfish. Extending arms either side, it allows a total of 4 magnetometers to be towed from a single ROTV. One advanced ROTV design consists of 4 horizontal columns connected by carbon fibre wing members in an open frame box arrangement. All 4 of these wing members have steerable fins, and this gives the design a fundamental advantage over other towed vehicles that can not only undulate, it can also move up to 80 metres either side of the centre line. So, what advantage does this give? Well, all towed vehicles are launched from the back of a boat directly into the stream made by the propellers. I mean, even when the line pays out and the vehicle starts to fall backwards and sink, it still resides in the cone of general water disturbance. So the main benefit for a vehicle able to move in 3 dimensions is that they can move quickly out of this turbulent stream. Pipeline surveys are a good example of how advantageous it is for ROTVs to be able to move in 3 dimensions. A conventional towed vehicle surveying a pipeline would see the mother vessel keeping carefully to the path above the pipe and the towfish following a parallel path just above the seabed. The winds and currents impacting on the side of the mother vessel, however, could probably push it 10-20 metres off track, and this would have the effect of moving the ROTV off target by the same amount. So the ability of an ROTV to move horizontally completely changes everything. The ROTV can now manoeuvre precisely, actually sit on top of the pipeline, almost irrespective of what's happening on the surface. If you want to know more about subsea engineering, read UT2, the magazine, an online magazine of the Society for Underwater Technology.